First, some reminders of the definitions we've covered in this section. A type 1 error is when we reject the null hypothesis even though it is true. A type 2 error is when we fail to reject the null hypothesis even though it is false. And power is the probability of rejecting a false null hypothesis. Errors are bad and are the result of either an unusual, non-representative sample from an unbiased method or some sort of bias. Power is a good thing. Let's look at some examples. Read through the following example, then answer, what are the observational units? What are the variables collected? Is each categorical or quantitative? And what would a type 1 error mean in this context? How about type 2? How about the power of the test? Pause the video and when you're ready, restart. The observational units in this example are the physicians, and for each physician I would record whether they took aspirin or not, and whether they had a heart attack or not. The null hypothesis was that aspirin does not prevent heart attacks, and the alternative is that aspirin does prevent heart attacks. So then to reject the null would be to conclude the alternative, or conclude that aspirin does help prevent heart attacks. Failing to reject the null would mean I cannot conclude that aspirin helps, or I cannot conclude the alternative is true. So a type 1 error then would be to conclude aspirin helps, even though it does not prevent heart attacks. What are the consequences of a type 1 error? People would be taking aspirin needlessly and may suffer some side effects from taking the aspirin. How about a type 2 error? In a type 2 error, I fail to reject the null, so I cannot conclude that aspirin helps, even though it does prevent heart attacks, even though the alternative is true. What are the consequences here? Aspirin could save lives, but we don't recognize its benefits. Make sure you understand which type of error could have occurred. Anytime I reject the null hypothesis, it is a potential type 1 error. Or if I fail to reject the null, that is a potential type 2 error. If, on the other hand, I knew that the null hypothesis was true, I could only make a type 1 error. Or if the null hypothesis is false, I could only make a potential type 2 error. How about the power of this test? Remember, power is a probability, the probability of correctly rejecting the null hypothesis, or the probability of stating aspirin does help when it really does help prevent heart attacks. Let's try another example. Recall the helper-hinderer study from the beginning of this semester? The null hypothesis was that pi is equal to 0.5, and the alternative was that pi is greater than 0.5, where pi is representing the true proportion of infants who would choose the helper toy. What would a type 1 error mean in this context? How about type 2? And the power of the test? Pause the video while you answer these questions, and then play to hear the answers. A type 1 error would be stating that infants prefer the helper when really they have no preference of toy. And type 2 would indicate that infants have no preference when really we do, or the infants do, prefer the helper toy. The power of the test would be the probability of concluding infants prefer the helper when they really do. Lastly, let's make sure we understand the probabilities involved in these errors. Power is a probability. It's the probability of correctly rejecting a false null hypothesis. In other words, it is a conditional probability, conditional on the null being false. Power is the probability of rejecting the null, given the null hypothesis is false. We could also write the probability of our errors in terms of conditional probabilities. A type 1 error is when we reject the null if the null is true. So the probability of a type 1 error is the probability of rejecting the null given the null is true. That actually is our significance level. So when we set alpha at the beginning of a study, we are predetermining the probability of making a type 1 error. The probability of a type 2 error is the probability of failing to reject the null when the null is false. Notice that both power and the probability of a type 2 error are conditional on the same event, conditional on the null hypothesis being false. And then they are the two options, the two decisions we could make in that situation. We either reject the null and have power, or we fail to reject the null and make a type 2 error. These are then complementary events. So power plus the probability of a type 2 error must sum to 1. You'll see these relationships in more depth when we work through the power simulation applet in section 3.5.